Okay, so this principles of flight question is a very short question, really, and not particularly difficult once we've seen how to do it. But there's a couple of easy traps to fall into, and the version as reported in the feedback isn't particularly precise. I've actually made this one more precise in its language. So an aeroplane is flying with a stall margin of 0.13 g. Now that relates to how fast the aircraft is flying compared to its stall speed straight and level. It's 1 g stall speed. And the aircraft, this is where I've sort of elucidated the question a little. The aircraft is in a level balanced turn. And if we go beyond a certain angle of bank, we know we will reach an accelerated stall. So any aircraft at whatever speed, if you bank hard enough in a balanced turn, the aircraft will reach the point of stall. What angle of bank will this aircraft achieve the stall? So what this means, the meaning of that first sentence, that the stall margin is 0.13 g, is that the aircraft will stall. So the aircraft will stall at 1.13 g. Okay, so that's really one of the areas where this question can become quite confusing. If you haven't seen it before, you might just not know what they mean by the stall margin of 0.13 g. If an aircraft is flying along at 1 g at the point of stall, then of course the stall margin is 0. So the stall speeds we talk about, VS1 and VS0, of course, for approach configuration, but primarily VS1, that's a 1 g stall. I often tell students, if you have an imaginary g at on your VS1, because that's always talking about a 1 g stall. So if we've got a stall margin of 0.13 g, that means we're flying at a speed where the aircraft will stall, at 0.13 g above that straight and level 1 g. That's what we mean by the margin. So steady straight and level flight, we're flying at 1 g. So we've got a margin of 0.13 g from the stall. That's not very big, by the way. This aircraft is flying below what's usually considered a safe airborne speed. So safe speed on departure is usually considered to be about 1.2 times your stall speed. And that would give you that would actually give you a margin of about 0.44. So this is actually flying below what would usually be considered a safe speed. So this takes the information from the first sentence and puts it in a more usable form. So we need to know that it will stall at 1.13 g. Now we want to know at what angle of bank that will be achieved. Well, we know, I hope you know by now, that the load factor in a balanced turn is 1 divided by cosine of phi, where phi is the angle of bank. If you don't know how to rearrange this, have a look at one of the maths videos. Both the ones I've made on the YouTube channel will explain how to rearrange equations. But what you will find is that I can rearrange this so that cos phi is then 1 divided by n. Yeah, and n being the load factor. Of course, if you didn't know, n is the symbol we tend to use for load factor. So n is 1.13 for the stall. So I've got 1 over 1.13. And 1 divided by 1.13 is 0.885, something like that, 0.885. So 3 decimal places. That's more than adequate precision. So if you want to find an angle knowing the cosine, then what we want is to use the inverse cosine function. So if I know what cos phi is and I want to know what phi is, then I take the inverse cosine of the value of cos phi. So in this case, I know that cos of phi is 0.885. So we want to take the inverse cosine of 0.885. You might see inverse cosine written as arc cos. That's not very common anymore, but it's occasionally written like that. On the calculator, on all the calculators I know of, that's written as cos to the -1, and that's shift cosine. So you want to press shift shift cosine of 0.885, or just answer if you've got the answer in there already. And the inverse cosine of 0.885 is 27.8 to 3 significant figures. That's close enough. And so the answer to this question is that the aircraft will stall at, so the stalling angle of bank is 27.8 degrees. And that's the answer to the question. Okay, if you have any questions about this, either write to me at the email address given at the beginning of the video or put in a comment below. Thank you very much.